The first definition we need to go over is central angle. A central angle is formed by two radii. In the circle P, if I draw in one radius and a second radius, angle APB is a central angle. Notice that P is the vertex of my angle and it's the center of my circle. A minor arc is a portion of the circle. Since it's a minor arc, it's the portion of a circle that is less than half. The notation for a minor arc. We start at point A and we end at point B. And instead of drawing in a line segment from A to B, we're going to draw in the arc from A to B. A major arc is a portion of the circle more than half. In our example, if we start at A and go all the way around our circle to B, we have a major arc. But we need to make sure that we don't go from A to B the short way. We need to go from A to B the long way around the circle. So we're going to include another point over here that I'm going to call C. So our major arc is ACB. Notice that the major arc has 3 letters when we name it. A minor arc can have 3 letters. If there was a point D there, minor arc AB could be written as minor arc ADB. A major arc has to have 3 letters. A minor arc can have either 2 or 3. A semicircle is a portion of the circle exactly half. In our example, if I draw in the diameter and label this point E, we have 2 semicircles. One that goes from E to B around the top of the circle, and one that goes from E to B on the bottom of the circle. Each semicircle is different, so we need to make sure to label each semicircle with 3 letters. EAB is this top semicircle, and ECB would be this bottom semicircle. Measuring arcs. If this line segment is the radius of a circle, if I make this the center of the circle and I rotate this radius around, I've traveled 360 degrees. And the measure of this arc is going to be 360 degrees. If I take that same idea and I make this line segment the radius of a circle with this point being the center, and I rotate this far, my central angle is going to be 90 degrees. And the portion of the circle that I've created is 1/4 of a circle. 1/4 of 360 degrees is 90 degrees. Hopefully you're starting to see a pattern. If I make this point the center of the circle and this line segment the radius, and I rotate so that my central angle is 35 degrees, the arc that I've created is also going to have a measure of 35 degrees. Let's get a little more specific. Let's label these points. The measure of angle APB is 35 degrees. Angle APB is a central angle where P is the center of the circle. The measure of arc AB is also 35 degrees. AB is a minor arc. If you look at these two measurements, they're the same. So I could say the measure of angle APB is equal to the measure of arc AB. This is the first formula that you're going to have to memorize. The measure of the central angle is going to be equal to the measure of the intercepted arc. The reason it's called an intercepted arc, it's the arc that the angle intercepts on the circle. Let's look at a couple of examples. In example 1, we have two central angles. This first central angle has an intercepted arc that measures 2x. Our second central angle has an intercepted arc that measures x plus 10 degrees. And if you look at these two central angles, they're vertical of each other, which means that they're congruent. And if the central angles are congruent, then the intercepted arcs have to be equal. So in order to solve for x, I first need to set up an equation. In this example, the two arcs are equal to each other. Now I can solve for x. X equals 10 degrees. So this arc would be 2 times 10 degrees, or 20 degrees. And this arc would be 10 plus 10 degrees, or 20 degrees. In example 2, I again have a couple central angles. But in this example, the central angles are not equal to each other. But if I look, these central angles form a semicircle. These central angles are supplementary. So the equation that I set up is 3x plus x plus 40 degrees equals 180 degrees. Same picture, different equation. Solve for x. Combine my like terms. Undo what's happening to x. (140 divided by 4 equals 35 degrees. So this central angle has a measure of 3 times 35 degrees, or 105 degrees. This central angle has a measure of 35 plus 40, or 75 degrees. In our third example, we have 3 central angles. And in this case, all 3 central angles add to a full circle, 360 degrees. So the equation that I set up is x plus 50 plus x plus 40 plus x plus 30. And I set that equal to 360 degrees, a full circle. Combine like terms. Combine like terms. Undo what's happening to x. (240 divided by 3 equals 80 degrees. So this angle is 80 plus 50, or 130 degrees, and this angle is 80 plus 30, 110 degrees, and this angle is 80 plus 40, 120 degrees. Now if I add 130 plus 120 plus 110, I should get 360, and I do. 3 different examples, 3 different equations that I need to set up, all based on central angles and central arcs.